So today we are going to start the topic of electrostatics. Plus two course syllabus we'll try to finish off in 4 to 5 months, and we'll stick to the basics. The electrostatics के basics से stick करेंगे and we will not go into the details. Competitive point of view है तो that will be a separate batch. So this will mainly be for the board exams. So electrostatics क्या होता है? We start with electrostatics. It is of two words, electro and statics. Electrostatics basically deals with, or we can say it's the study of electric charges at rest. It is the study of electric charges at rest. When we say electric charges at rest, we are not talking about the absolute rest. Absolute rest of charge is not possible. Study of electric charges at rest means that charges being microscopic particle, they are always in motion. They can be at rest only at 0 Kelvin. They can be at rest at 0 Kelvin, but their motion is random. Inside a conductor, when electrons move, they are moving in a totally random manner. They are traveling a lot of distance. They are traveling with a speed of 10 raised to the 6 meter per second, but their velocity is zero. So there is no preferred direction in which they are moving. So in such cases, we can say that charges are at rest. So charges at rest only implies that average velocity of electron is zero. Average velocity of electron is zero, but average speed is not zero because electrons are moving with the speed of 10 raised to the 6 meter per second. Or you can assume that if you have a large conductor and you consider a small part of it, if the number of electrons entering that given region is equal to the number of electrons moving out of it, you can assume that charges are at rest. So it's an assumption. Absolute rest of charges is possible only at 0 Kelvin. Except 0 Kelvin, charge particle cannot be at rest. So इसमें हम एक special case we will study where the average velocity is zero, the electrons don't have a preferred direction of motion. So absolute rest of charges is possible only at 0 Kelvin. Except 0 Kelvin, they cannot be at rest. Now, this is which we are going to study in first chapter, charge particle rest pair, and what will be the electric field generated by charge particle, potential energy, and the end capacitance. Second is electrodynamics. Electrodynamics deals with charges in motion when they have a preferred direction, when current flows. So we say electrodynamics is branch of physics which deals with charges in motion. Branch of physics which deals with charges in motion is electrodynamics. Branch of physics dealing with charges in motion. There is current flow through conductors. Now, when we study the current flow through conductors, we will also study that the magnetic effects related with the current flow and the electromagnetic effects. So अभी हम stick करेंगे कि electric charge is at rest पे. Now when we are saying charge, we say it's a fundamental property. Fundamental property, there is no definition as such of charge. We know the effects produced by charge, that it generates electric field, or you have to do some work when charge part you're moving your bodies against this electric field. But charge, we say it's a fundamental property. And this concept was introduced by Benjamin Franklin. He was doing an experiment that he rubbed glass rod with silk. He found both glass rod and silk acquires some property. The glass rod is rubbed with silk. Both acquire some property. He said property acquired by glass rod. He named it as positive charge. So positive and negative are just the names. There is no mathematical significance associated with it. And silk acquires a property which he calls as negative charge. Now, at that time, the concepts of electron, proton, that was not developed as yet. But now we know the reason that why it happens. We say that when you rub two bodies, you have to do some work against friction. So you can say this is the concept of frictional electricity. Then you rub two bodies against each other, you are doing some work against the frictional force. Now, when you are doing work against the frictional force, you are giving energy to the system, and that can be used to transfer electrons from one body to another. Now, which body will gain electron and which body will lose electron? That depends on the electron affinity. The body having greater electron affinity to attract the electrons, that will be gaining electron, and the other body will be losing electrons. So we can say when you rub two bodies, electrons are transferred from one body to another. The body which gains electrons acquires negative charge, and the body which loses electrons acquires positive charge. So it's a concept of frictional electricity. Transfer of electrons takes place. When two bodies are rubbed together. Body which gains electrons acquires negative charge. Body which gains electrons acquires negative charge, and the other body acquires other body has positive charge. Now this positive negative concept is कि initially when you have a neutral body, it's not that it has no charges. Neutral body has equal number of positive and negative charges. So net charge on a body is zero. When electrons are transferred, like one body loses electrons, initially number of positive and negative charges are same. The net charge is same. The total amount of positive charge is equal to total amount of negative charge. Now when electrons are transferred out of that body, the positive charges becomes more than negative charge. So we say that body is positively charged. Whereas the other body, which is also initially neutral, when it gains electrons, the number of net negative charge, and net negative charge becomes more than the net positive charge. So we say that it has a negative charge. So it's not कि when a body is neutral, it doesn't have charge. Neutral body has equal amount of positive and negative charge. Gaining electrons, net negative charge becomes more, and losing electron, net positive charge becomes more. So that's how the bodies gets charged. This is just one method of charging, and it's known as frictional electricity. There are two methods, charging by contact and charging by induction, but they're not actually in the CBSE syllabus nowadays because CBSE has deducted this part of methods of charging. But they will be required when you prepare for competitive exams. And whatever we are doing, the notes for this will be uploaded on your school's website. So you can just check it out from there. Whatever we do in the class, by the end of the class, lecture will be uploaded and notes will be on the school website. Next is the properties of charges. We can start with the simplest property that like charges repel each other, unlike charges attract each other. The formula for that we will do later on Coulomb's law, but at present you can say the property is first property is that like charges repel unlike charges attract each other. In this case, there is one important conceptual question which is asked. We say like charges repel unlike attract. Repulsion is sure test of electrification of both the bodies. Now, when we say sure test of electrification of both the bodies, repulsion can take place only if both the bodies are charged and similarly charged. Attraction can also take place if one of the bodies charged and the other body is neutral. So this electrostatic attraction is not sure test of electrification that both the bodies are charged. Attraction can be between a positively charged and a neutral body or a negatively charged and a neutral body. Whereas repulsion can take place only if both the bodies are similarly charged. So there is a conceptual which is asked in board. Repulsion is show test of electrification of both the bodies. Because attraction can take place between charged and a neutral body. So only when two bodies repel, then only we are sure that both the bodies are charged. Now, this is the simplest property. Next property is important one. Quantization of charge. Quantized physical quantities are those which cannot have discrete values. Which cannot have discrete values means which have discrete values. They cannot have continuous values. Continuous values होते हैं like you can have mass. You cannot have a minimum value of mass. Between 1 gram and 2 gram, there can be infinite values of mass possible. It can be 1.1 gram, 1.11 gram, 1.111 gram. So we say mass is not a quantity which is quantized. Charge has discrete values. It doesn't have continuous values. You have charge in multiples of certain smallest value. So when a quantity doesn't have continuous values and its value increases in jumps, we say that it's a quantized quantity. For example, like you have already done in chemistry, angular momentum of electron revolving around the nucleus is quantized. Bohr's second postulate that angular momentum of electron cannot have any random value. It's always multiple of h by 2 pi, where n is any integer and h by 2 pi. Similarly, we say that charge is quantized. It cannot have any value. It's always an integral multiple of a minimum value called quanta of charge, which is charge on electron or proton. So we say charge is a quantized physical quantity. A charge cannot have continuous values. It is a it has discrete values. We say charge on any body. It's always integral multiple of certain minimum value called quanta of charge. E is called the quanta. There's the minimum possible value. And its magnitude is 1.6 into 10 raised to the power minus 19. And n is any integer. So we say charge on any body is always integral multiple of certain minimum value called the quanta of charge. Quantization basically means that n cannot be a rational number. N can't be a rational number or in fractions. N cannot be a rational number or in fraction means that n cannot be a rational number or in fraction means that n is always multiple. You cannot have a charge on a body as 1.28. You cannot have charges 7 by 5e. You cannot have charges 3 by 2e. So charge cannot be a rational multiple of e. The logic is very clear. A body is basically charged when you transfer the electrons from one body to another. And charge on electron is E. So you can transfer one electron, two electrons, three electron. You cannot transfer 1.5 electrons or 3/4 electron. So because it's due to the transfer of charge, electrons, you cannot have fractional values. But in recent studies, in 70s, 80s, say past, you can say 30, 40 years, another concept came into being, which is quarks. Now, when we talk of quarks, we said these are the particles of which hadrons are made of, strongly interacting particles. These are particles of which hadrons are made of. Now, hadrons के आपने भी दो एग्जाम्पल पढ़े हैं, न्यूट्रॉन एंड प्रोटॉन. These are hadrons. Otherwise, it's a strongly interacting particle, large family. Now, these hadrons are always made of quarks. Quarks exist in six varieties. up, down, top, bottom, strange, and charm. These are again the names. But if we will just focus on two at present, say up quark, there's the name. It has a charge of plus 2 by 3 in down quark, which has a charge of minus 1 by 3. Now, when we say up quark and down quark, we just stated that quantization implies that charge cannot be in fractions. But here the charge is in fractions. That you have a charge of 2 by 3 and minus 1 by 3. And this was experimentally verified also, because if you take proton consists of 2 up and 1 down. So up quark has a charge of 2 by 3, so 2 up quarks. And 1 down quark. So net charge is E. Whereas neutron consists of 2 down quark and 1 up quark. So neutron has a charge of 0. Now we say quarks have fractional charges. They are experimentally verified also. But they don't break the quantization principle. Because till now, we don't have independent existence of quarks. They always exist in groups. Like this, there is a group. Up, up and down, and there's down, down and up. They always exist in groups. And the total charge on a group is quantized. कि group पे जो charge है, that is quantized. This is not a fractional multiple, this is not a fractional multiple. So we say they always exist in groups and the charge on a group is quantized. So reason we say is quarks don't break quantization. Quantization principle because they don't have independent existence of their own. Like they don't exist or found alone or separated from the group. They don't have independent existence yet. Maybe in future we can separate and we have to change. Don't have independent existence. They always exist in groups. They always exist in groups. And charge on group is quantized. The minimum possible value of charge, like we have said E, this is called the quanta of charge. So, first property was simple, like charges repel unlike charges attract each other. Shortest is repulsion because attraction can be between a charged body and a neutral body also. Second is quantization. The total charge is quantized. Third, you have invariance of charge. Now, when we say invariance basically means that charge is a physical quantity which does not vary. And when we say relativistic invariance, now relativity is a branch which deals with velocities comparable to the velocity of light. Einstein predicted that whenever things are moving with velocities comparable to velocity of light, even the fundamental properties change. Mass increases, length decreases, time dilation occurs. But charge is a quantity which is invariant relativistically also. This basically implies that whatever be the velocity of charged particle or the speed of charged particle, the magnitude of charge on it will not change. If we say electron has a charge of 1.6 into 10 raised to the power minus 19 coulomb, even if electron is moving with a higher speed, instead of 10 raised to the power 6, it's moving with a speed say 99% of the speed of light, the magnitude of charge on the electron remains same. So that is called invariance of charge. Relativistic invariance of charge. Is a charge is a quantity charge on a body or particle will not change its magnitude, will not change in magnitude, even at speeds comparable to speed of light. We will not say speed of light because speed of light is only those particles can move which are massless. So whenever a particle has charge, it has some mass also. Now this is one term. The charge on a body does not vary with the speed. But we know that mass varies. And for that there was formula which we have used in 11th class also. That mass varies with speed according to this formula. Now, if you increase the value of V, the denominator will decrease and mass will increase. So we say increasing, that if V increases, mass of the body also increases. Sometimes in board exams, they ask about the specific charge rather than charge. Now, when we say specific charge is different from charge. Specific charge we call Q by M, charge to mass ratio. We are saying that Q is invariant. Q is invariant quantity, but mass increases with speed at relativistic speeds. So that means numerator is constant and denominator increases. That means Q by M decreases. The Q by M decreases with increase in speed of the charged particle. So there's the third property. First was like charges repel, unlike charges attract. Second is quantization of charge. The charge has a discrete physical quantity, it cannot have continuous values. Third property is invariance of charge. Fourth is what is mentioned in the board syllabus, conservation of charge. Now, what we mean by conservation of charge? Conservation of charge. Normal definition we give that charge cannot be created. It can be charge can neither be created nor destroyed. It can be transferred from one body to another. But the better definition is that in an isolated system, total charge always remains constant. In an isolated system, total charge remains constant. Like in frictional electricity. So you have two bodies of different materials A and B. Charge on both the bodies is zero. Conservation implies that when you rub, the positive charge required by one body is always equal to negative charge required by the other. After rubbing, if A has a charge of plus Q, B will have a charge of minus Q. So the total charge remains zero. So that's conservation of charge. Now, you have to note one thing also, which is important. Then, when two bodies are rubbed, the positive charge required by one is negative charge required by other. There is change in mass which also takes place. Or you can write reaction like electron combines with positron to form two gamma rays. Charge on electron is positron is positive electron. Positive electron means charge equal to electron and mass equal to proton. And this is neutral. So we can say इनका भी charge रहा, that's zero. So there is an example where 100% mass is converted into energy. 100% of the mass is converted to energy. Now, when we talk of change in mass on electrification, change in mass on electrification means if you are transferring the electrons, say body is gaining electrons, that means it has acquired some mass, and the body which has lost electron, it has lost some electrons. So whenever we say that a body is charged, there is always a change in mass which takes place with it. So that's we call it change in mass on electrification. When you charge a body, its mass changes. Change in mass on electrification. Like if you give a charge, positive charge to a body, positive charge always implies loss of electrons, and negative charge implies gain of electrons. Now, when we say gain of electron, that means mass is increased. Loss of electron means mass will decrease. So, positively charging a body results in decrease in mass. Now, how much mass will decrease? That we can find using quantization. Like if you have a body is given charge Q, say plus Q. Plus Q means it has lost electron. We say that Q is any. Now, if it is a charge Q, It means it has lost n electrons. To give a body charge q, it has to lose n electrons. Now, if a body loses n electrons, it will also result in decrease in mass. So decrease in mass कितना होगा? If you have एक electron का mass, if you know, say it's 9.1 into 10 raised to the minus 31. If it has lost n electrons, so decrease in mass would be number of electron lost into mass of one electron. And number of electron lost are, so this is the formula which you can use to find that what will be the change in mass which takes place when bodies are electrified. Negative mass दे रहे हो, negative charge दे रहे हो, तो मतलब it has gained electrons. Positive charge means it has lost electrons. So there is another property of charge. Charge and mass में the basic difference you should remember. Charges always, they both follow the similar kind of laws, inverse square law. But force between masses is always attractive, whereas charges can be attractive as well as repulsive also. Both are long range forces. They can act up to any distance. As you increase the distance, the magnitude of force goes on decreasing, but force still exists. So पहले इतनी प्रॉपर्टीज को समझ लो. हमने जो आज किया that conservation, quantization, invariance, and like charges attract. Another is which you will be using number of numericals. That's called additive nature of charge. Additive nature of charge means if you have a number of bodies in a system, a number of particles in a system, the total charge on the system is sum of all the charges. You just simply add positive with the positive, negative with the negative. Scalar addition, it's not a vector quantity. So that's called additive nature of charge. Charge is a scalar quantity. And total charge on a system is scalar sum of charge on individual bodies. Like you can say total charges, simply add. Now there's another thing you have to take care of. Okay, how the charges creates field. There are three cases. A charged particle at rest. It creates electric field. It can be uniform, non-uniform, depending on what sort of charge distribution is there. But a charged particle at rest creates electric field. Charged particle in uniform motion. We say it creates electric as well as magnetic field. And a charged particle in non-uniform motion or accelerated charged particles. We say it's radiating electric and magnetic field or EM waves. Radiating electric and magnetic field or EM waves, as you have done in Rutherford modeled effects. Electron being an accelerated charged particle when it moves in a circular path. Because it's an accelerated charged particle and it radiates energy and it should fall into the nucleus. So whenever you have charged particle which is accelerated, it radiates electromagnetic waves. And that is what is used to generate EM waves for the first time by Bose and Hertz experiment. That where the charged particle are accelerated to generate EM waves. So this is the just first lecture, properties of charge, and tomorrow we'll do the Coulomb's law. I will upload the theory part of this on the school website, so you can check it from there.